Okay, we're going to look at solving quadratic equations in this video by factorizing. We're going to focus on the method of factorizing. So all quadratic equations can be written in this form: ax squared plus bx plus c is equal to 0. It's called standard form. A, b, and c are numbers, constants, and a can't be 0 because if a is 0, this isn't a quadratic anymore. So the key thing is you want to bring everything over one side and make it equal to 0. Okay, you also need to expand brackets, remove fractions to arrange in this particular form. Okay, sometimes quadratic equations can have one solution, sometimes they can have two, or sometimes they can have no solutions, and we'll see that. The key property that we're going to use for solving by factorizing is that if you've got two things that are times to give 0, either the first is 0 or the second is 0. Okay, or both at 0. Okay, so if you think about it, that should make sense. You've got 3 times something equals to 0. The only thing this can be is 0, right? Yeah. 2 things times to give 0, one of them or both need to equal to 0. So if I want to solve this, I've got 2 things times to give 0. So either the thing in the first bracket equals to 0, or the thing in the second bracket equals to 0. So solving this, that x will be equal to 2, or if you minus 1 then divide by 2, x will be equal to -1/2. Okay, hopefully this rings a bell, and hopefully you can remember some shortcuts to go straight from here to the answer. For example, if it's just a 1x term, you would just change the negative to a positive there. You change the sign in front of that back bit. Here that's a 2x bit, so we change the sign for the n bit, so it becomes -1, and we divide by the coefficient of x, so that 2 pops down the bottom. Okay, and it's perfectly acceptable in exam to go straight from that straight to the answer in one line there. So let's get a bit of practice with this one. So for this one, either x is equal to 0 or x minus 3 is equal to 0. So we've got our two options: x is equal to 0 or x is equal to 3. And hopefully we can get straight to that bottom line there. Key thing for this bracketed bit, that -3, we change the sign to +3. Okay, here we've got a perfect square. Well, what does that mean? That just means x minus 1 times x minus 1 is equal to 0. So for both of these, hopefully you can see by changing the sign, you would have x minus 1 is equal to 0, which is equivalent to x being equal to 1 for both of them. Okay, so you only need to write it once. Okay, when you get your answers, I suggest box them to make them really clear. Okay, hopefully we're good enough to be able to jump straight to the solution after we've got it factored equal to 0. So, solving quadratic equations using factorization. Okay, so first step, rearrange into standard form. Bring everything to the left-hand side. Factorize using the techniques we've learned from chapter 1. Then we use the property that if a times b equals 0, then either a is 0 or b is 0. So, first one. So, first step, everything to the left, good. Now I'm going to look for any highest common factor. There is none. Now I'm going to notice that's 2 terms. That's a difference of 2 squared. That's x squared minus 4 squared. Okay, so that factorization will be x plus 4, x minus 4. Okay, so therefore the first solution will be x is equal to -4, just changing that sign, or x is equal to +4, just changing that sign. So they're my two solutions there. Okay, this one, everything's on one side equal to 0. That's good. Take out the highest common factor of 2. We get x squared minus 25 is equal to 0. So once again, this is a difference of 2 squares because that's x squared take 5 squared. So that's going to be x plus 5, x minus 5 factored. Okay, now it's important to note 2 can't equal to 0. But this bit can equal to 0 or this bit can equal to 0. So changing sign, I've got x is equal to -5 or x is equal to 5. They're my two options there. You don't really need to write that 2 cannot equal to the 0 bit in your solution. Okay, question 3. Let's bring everything over to the side where the coefficient of x squared is positive. So minus 25 from both sides. Okay, can't take out a common factor. Notice that this is a difference of 2 squares with 2x all squared minus 5 squared. So the factorization here will be 2x plus 5, 2x minus 5 equal to 0. Okay, so let's try to remember how do we do it when there's a coefficient not equal to 1. Okay, so x is going to equal to, remember we changed the sign of the back bit, so negative 5, and then over, and we divide by coefficient of x, over 2. Or x is equal to, change that negative 5 to positive 5, and write over 2. We divide by coefficient of x. So that's the shortcut way for that particular one. If you want to do the intermediate step and do it the long way, that's fine, but I think you should be good enough to do the shortcut. Okay, we'll come back to those 3 questions. I'll show you a different method of doing that in a moment, a bit later on, maybe at the end. I'm also going to skip 6 for the moment. We'll come back to that later. So this particular one here, x squared minus 4x is equal to 0. Okay, it's not a difference of 2 squares, but we can factorize out an x. And then bracket x minus 4 is equal to 0. So either the first equals 0 or the second equals 0. And remember, to solve for that, we'd bring the negative 4 over the other side and we become positive 4. So x is 0 or x is 4. Just to comment about this particular question, a trap that students fall into is they decide that they're going to divide both sides by x. Be careful when you divide by a pronumeral. You might be dividing out an answer because we're assuming that we're not dividing by 0. Okay, if you divide by x, you'll get x minus 4 is equal to 0, so you get x equals 4, but you lose a solution of 0. Okay, because when you're dividing by the x, you're assuming you're dividing by something that isn't equal to 0, because if you divide by 0, that's nonsensical. So key thing is when you solve, don't ever divide by letters. Don't divide by letters. Don't divide by pronumerals. Don't divide pronumerals. Instead, factorize. Okay. Alright, that's the key message there. You can lose a solution when you divide by pronumerals. Alright, this particular one. When you see 3 terms like this equal to 0, 3 terms as a trinomial, I think PSF method. So product of the back number, which is 4, sum of the thing in front of the x, which is negative 4, factors. I reckon 2 with negatives on both. So x minus 2 times x minus 2 is equal to 0. So look, because both brackets are the same, I only need to solve one of them. I'm going to get the solution x is equal to 2. So here's an example where there was only one solution, x is equal to 2. Alright, I'm going to skip 6 for the moment. Let's do 7. Let's bring everything over one side. I'm going to bring the minus 2x squared over the other side to make it positive coefficient of x squared. So that's going to be 2x squared plus 4x. I'm going to factor out a 2x. X plus 2. So either the first is equal to 0, so 2x is equal to 0, or the second is equal to 0. And if I divide by 2 quickly, you'll get that x is 0 or x is negative 2. And hopefully you could have skipped a line there to get to that answer. Okay, next one. We've got a product of 8, a sum of 6. Factors, I reckon 4 and 2 work. By the way, how do I know to use PSF? I see 3 terms. 3 terms equal to 0, use PSF. So x plus 4, x plus 2 is equal to 0. So therefore x will be equal to negative 4 or x will be equal to negative 2. Okay, just changing the sign for each of them. Okay, this particular one, now it's not in the standard form that I want. Standard form has everything expanded and brought over one side equal to 0. So first step is expand that bracket out and bring everything over one side. So x squared minus 2x minus 3 is equal to 0. I've got 3 terms, so it's a trinomial. Use PSF method. So product of negative 3, sum of negative 2. Factors 3 and 1 with negative on the 3. That works. That adds to give negative 2 and times. Yep. So it's x minus 3, x plus 1 equals 0. And now to solve, we just change the signs. So x is equal to 3 or x is equal to negative 1. Okay, moving on. Question 10. Once again, this isn't in the nice form that we want. So first step is I'm going to expand. So expanding this is a difference of 2 squares because x minus 4, x plus 4. So that's going to be x squared minus 16, difference of 2 squares, equal to 6x. Let's bring the 6x over, so x squared minus 6x minus 16 equals 0. It's a trinomial, so therefore PSF method. Product of the back, negative 16, sum of negative 6. I think 8 and 2 with a negative on the 8 will work. That sums to negative 6, yes. So x minus 8, x plus 2 equals 0. So solving this, it will equal to 8, or x will equal to negative 2. Just changing those signs there. Good. Okay, this particular one is not in the form that we like. We want everything on one side equal to 0, and there's also a fraction, so we need to deal with that. So you've got a few different options here. I'm going to create a common denominator for this right side of x. So I'm going to times the 9 top and bottom by x. So I'm going to get 9x minus 18 all over x. And now I'm going to cross multiply. So that's going to become x squared, because x times x is x squared, equals 9x, take 18, bring everything over the left. X squared minus 9x plus 18 equals 0. It's a trinomial, so PSF method. Product of 18, sum of negative 9, 6 and 3, negative on both, I think will work. Yep. Negative 6 plus negative 3 is negative 9, that works. So x take 6, x take 3 equals 0. Switching the signs for the final answer, x is equal to 6 or x is equal to 3. Okay, next one. Once again, it's not in the correct form that we like, so I'm going to cross multiply straight away. So it's going to equal to 2x there. And then let's bring everything over to the side where the coefficient of x squared is positive. So bring everything over the right hand side there. So it's going to be x squared plus 2x, and bringing the 35 over, it'll change to negative 35. We've got a trinomial, 3 terms, so PSF method. Product of negative 35, sum of 2, factors of 7 and 5 with negative on the 5 will work. So x plus 7, x minus 5. To solve, we change those signs, negative 7 or x is 5. Okay, 13. This question looks a bit interesting because it's got a 3 in front of the x squared, so it's non-monic. However, we can notice we can take out a common factor of 3 everywhere. So always look to take out that highest common factor first. So minus 5x plus 6 equals 0. And now I'm factorizing this inside bit. It's monic, so that makes it nice and easy. So product of 6, sum of negative 5. I reckon 3 and 2 with negative on both. Yes. So x minus 3, x minus 2 is equal to 0. Okay, there's no way 3 can equal 0. So next bracket, changing that sign, x will be equal to 3. And for this one, changing the sign, x will be equal to 2. So there's my 2 solutions there. Okay, next one. It's not in the form that I like, so I'm going to need to expand. So let's expand the binomial. So that's going to be 2x squared, and then 2x times 5 is 10x. Then this bit is going to be 1x, and that's going to be plus 5 equals to 4x. Let's collect like terms. 2x squared plus 11x plus 5 is equal to 4x. It's minus 4x from both sides because we need to make it in standard form. So we're going to go 7x there. Okay, this is non-monic and there's nothing we can do about it. We can't take out the common factor of 2. So remember, for non-monic we still use PSF method, but there are a few different changes. So we times 2 times 5 first. So front times back for non-monic, so that's 10. Sum of 7, so factors of 5 and 2 work. And also remember, for the non-monic, we split the middle term with those factors. So that 7x is going to split into a 5x and a 2x. So 5x plus 2x. Okay, let's take out a common factor here. So now we've got 4 terms we group in pairs. Remember this, how we solve the non-monic ones? So take out an x there, that'll be 2x plus 5. And I'll take out just a 1 here, that'll be 2x plus 5. And we can see the common factor of 2x plus 5. And then bracket x plus 1 is equal to 0. Alright, I'm going to need to finish this off in the next video. I'll see you soon.